Solid sodium hydrogen carbonate decomposes to form solid sodium carbonate, liquid water, and gaseous carbon dioxide. So we need to write the balanced equation first. Sodium hydrogen carbonate, sodium is Na, which has a +1 charge, and hydrogen carbonate is a polyatomic ion, HCO3, and has an overall -1 charge. +1 and -1 will cancel. It's going to decompose, so we draw the yield sign. It's going to form sodium carbonate. So again, sodium is a +1. Carbonate is CO3, which has an overall -2. We're going to have to crisscross or flip-flop these charges. This means I need 1 carbonate, and this means I need 2 sodiums. And so now we've finished using the charges. We're going to have liquid water and carbon dioxide gas form. So now that we have written the equation, we need to make sure that it's balanced. So there is 1 sodium on the left, but 2 on the right. So I'll need a 2 here. This gives me now 2 hydrogens on the left, 2 hydrogens on the right, 2 carbons on the left, 2 carbons on the right, and 2 times 3 is 6 oxygens on the left, 3, 4, 5, 6 oxygens on the right. So now that I have the equation balanced, let's go ahead and recognize that we've been given a piece of information at the end of the problem, the density of carbon dioxide, which is 1.786 grams per cubic centimeter. So that can be seen as a conversion factor. 1.786 grams of CO2 is equal to 1 cubic centimeter of CO2. Since we are asked to find what's the volume of the gas, and by the looks of the answer choices, we need our answer to be cubic meters, we're going to need to use this density at some point in the problem. We are given 74.0 grams of the sodium hydrogen carbonate as our given amount to start. So we're going to stoich from here to here. So we'll start by putting 74.0 grams of sodium hydrogen carbonate over 1. We'll bring down grams of sodium hydrogen carbonate, and this can be calculated by typing in the mass of sodium plus the mass of hydrogen plus the mass of carbon plus 16 times 3, which is the mass of oxygen times 3. So this gives us a mass of 84.01 grams of sodium hydrogen carbonate. This is equal to 1 mole of sodium hydrogen carbonate, and now we can bring down our moles of sodium bicarbonate and do our mole to mole ratio from sodium bicarbonate to carbon dioxide. There are 2 moles of sodium bicarbonate to 1 mole of carbon dioxide. Now we can go from moles of carbon dioxide to grams by going to the periodic table and adding up 12.01 plus 16 times 2, which is equal to 44.01 grams. Here's where we can use our density. I'm going to bring down grams of CO2, and we can go to cubic centimeters of CO2 by inserting 1.786 grams in the denominator, which is equal to 1 cubic centimeter in the numerator. Finally, we need one more little step where we convert cubic centimeters to cubic meters, and 1 meter is equal to 100 centimeters cubed. However, 1 meter is equal to 100 centimeters, but since they're both cubed, I'm going to have to cube these 2 numbers as well. Okay, so to type this into our calculator, we would type in 74.0 divided by 84.01 divided by 2 times 44.01. Then we're going to do divided by 1.786, and then here we're going to hit divided by 100 cubed, which is equal to 1.085 times 10 to the -5, which is equal to letter C.